is equals to 102. Take a picture there so you can. Oh, I'll see it here. Let me see it here. Let me just write it like this. Yeah. So the third one says that we should. Let's say we're given. Let's say if we're given S, which is equals to 1002 0
What's going on?
The pen died.
Oh, shit.
This one is there though. It's a sign. When the Lord calls you, He calls him always. Where do I plug it?
This side.
It only has one?
No, two.
Why not?
Yeah, okay. Hi.
Amen. Aşkına das no. Yeah, let's see. I just put it in with my hand. So the other one we're having 0 minus 3 5. American money. Minus 1 wabetrababayini. And then the other one is how many are there? 5.
Negative 1.
4 minus 2. Double look over the boy infinite of this one. And then we have 7 1 2 9. And then the last one, yeah, the last one we have, oh, there's still space. We have 5 1 4 2. They say that all this is happening in M2 by 2. So since we're given this question, the question says we should check if this forms a basis. All right. Does S form a basis? Does it form a basis? So first thing that we're gonna do, always as usual, we're gonna do the same thing. We're gonna act as if we're checking spanning first, meaning that we're going to let we must let a 2 by 2 matrix to be an element of M22 such that this can be expressed as a linear combination of all these. Alright. A, B, C, D. We say it's equals to X 1 0 0 2 plus Y say 0 minus 3 5 minus 1 say plus let me just say Z. Let's say 4 minus 2 1 6. We say plus W. Then we say 7 1 2 9. We say plus P 5 1 4 2. All right, and then we equate this A B C D so that this will be equal. So we add the first entries. The first entries will be X Y. It will remain as 0, so I won't add it, plus 4Z. So first entries are these ones, the ones which I'm adding, multiplied by the constant. Alright, and then this will be 4Z. After 4Z is 7W plus 5P. We added this. This will need a set of space. This is X plus what? 4Z, right? 4Z plus 7W plus 5P. Then we add the second entry. It does not have x, right? It's 0. It's minus 3y minus 2z, right? And then W, and then plus p. Yeah. Then we come to the second ones. There's no x, right? It's just 5y z 2w. 5y z 2w. And then the last one is what? 2x, right? 2x minus y plus 6z. Didn't they include p on the last one? This one didn't include p. It's what? Plus 4p. Yeah. Then this one is plus 9w plus 2p. Yeah. So now we equate them. How many equations are we going to have? 4, right? These are going to solve. Then after this, I will show you how do. Let's say you wanted to skip this, but you don't skip, right? You just want just to confirm. I'll show you how do you confirm. Why? But that one is we labeled it as. I mean this one, right? It's 2x. Let's see. Yeah, it's this one. 2x.
Then the last one.
The last one is 2p. Yeah. Then this will be a is equal to x plus 4 z plus 7w plus 5p. And then the second one is b, which is minus 3y minus 2z plus w plus p. Then the third one is c equals to 5y plus z plus 2w plus 4p. Then the fourth one, d is equals to 2x minus y plus 6z plus 9w plus 2p. So we put this in an argumented form. Remember our form is always like this. Alright. And then this will make sure that we confirm everything being correct. So we have 1, 4, 7, 5. Then how many variables do we have? We have x. It's y after x, right? Y, z, w, and then p, right? And it shows that it's how many here? Must also have a what? Okay. Oh, yeah, we'll do that. And then here, so I want to check if this one will be the system. You can check from here if the system would work out or not, right? So if you check here, we have here for b, there's no y here, right? So it's 0, then y here will be minus 3, then minus 2z. Okay.
Before 4.
Oh, for z, ne? Yeah.
For y.
For y, no, yeah. So this one. 1, 0, 4, 7, 5. Minus 3, minus 2, 1, 1. Yeah, let's check. We can check the system when we're done actually. Let me now just fill this. 5, 1, 2, 4, right? 2 minus 1, 6, 9, 2. Then for us to check if the system is correct, if we've entered everything correctly, this one is a what? It's a 4 by 5 matrix, right? This one is 5 by 1. So these ones they should always be equal to show that your matrix is correct. So this will be equal to, we have what here? A, B, C, D, which are 4. For again, we have 4 rows. You agree, right now? And that is correct. Now from here, I said that we have many methods we can check if this is a spanning set, also it's linearly independent. One of the methods which we can use is determinants, because this is not a square matrix. You see right now, so we can use determinants. So it means that we are forced to use the other methods. So since we want to check if this is a spanning set, we can just come here and say we're going to use this. So we're going to use it here. And then we have A, B, C, D. All right. Another thing, let's say you wanted to check how do I put these matrices here. You said right now, or to confirm them if they are correct. If we check these ones, let's check these ones for X. The first one, you said right now, it's what? Well, let's check here. It's 1, 0, 0, 2. You said right now. So when we come here, we look at this, we get 1, 0, 0, 2. You said right. When we come to the second one, we get 0, minus 3, 5, minus 1. So it's 0, minus 3, 5, minus 1. You say right, which is this one. Then we'll check the third one. It's 4, minus 2, 6. 4 minus 2, 6. We check is 4 minus 2, 6. This one, right? And then the fourth one and the fifth one. So they will all be like that. Or, instead of checking them like that, you can also check them in this way. You can say, if we check, this is 1, 0, 4, 5. You say right, let's go. It's 1, 0, 4, 5. The first entry will always be, the first entries will always be the first row. You say right. And then we check the second entries will always be the second row. It's 0, minus 3, minus 2, 1. 0, minus 3, minus 2, 1, 1, right? Minus 3, minus 2, 1, 1. Yeah. And then the third one will always be the third row. We see musne like that. So it will be 0, 5, 1, 2, 4. So you can always confirm like that. It is a bad move to just start from there and say the matrix is like this. So you should always make sure you show the previous calculations of showing linearly in the combination until you arrive there. So from here it means that we need to highlight, let me see, they are not accordingly. Yeah, you should make sure you write them accordingly, right? So we're going to highlight those, let me see, did I highlight correctly? No. How many? Oh, that's why we can't highlight correctly. I say why they're not accordingly. So we're in what space here? M22, right? So we need to come here and check this. The dimension of M22, it's like this. We must check this. The dimension of M22 will always be equal to this by this. You say right now, 2 by 2. So which is 4. You must know that we're in the space of 4 right now. So it means that we must check if we have 4 leading ones. We can check it if we have 4 leading ones. We agree, right? So for us to check that, let me just erase this. We leave that out. So for us to check that, we must change. Already these ones are changed to a 0, so we are fine there. Anything that is below this should be changed to a 0, right? So we're going to change this. Let's start by changing this one to a 0. 1, 0, 4, 7, 5. A. This is 0, minus 3, minus 2, 1, 1. B is 0, 5, 1, 2. This is 4, right? 4. C. Then once you change that to a 0, it's row 4 minus row 1, right? But the constant of row 4 is 2, the constant of row 1 is 1. So we divide. Like when we we don't divide. We're not using a quotient where you are interchanging. So when I interchange, I'm gonna give this 2 to row 1. You say right? Then this will be a 0. Minus 1 minus 0 will be as a minus 1. Hey, why am I writing 0? Then 6 minus 8 will be minus 2. Don't forget I'm taking this, then I plug 4 here to get minus 8. Then I say 6 minus 8 is that. Then 9 minus 14. What is 9 minus 14? Is it 5? Minus 4, 5? Then 2 minus 10 is minus 8. Then this is D minus 2A. Alright, if we highlight that diagonal entry, those diagonal entries, we realize that we are left now to change this to a 0. Alright, now we change those to a 0. Let's change this and this to a 0. And we'll come back. But the best one would be to change this to a 0. It's fine. Let's just, we can change this to a 0 together. So we're going to say here 1 0 4 7 5 A B 0 minus 3 minus 2 1 1. Then change the row 3 to a 0. We'll have to subtract the row 2, right, which is here. So we take the constant of row 3 is 5, this is minus 3, and then we interchange, right, the constant. So it means that this one will be 5, this will be minus 3. We interchange their constants. So when we come, this will remain as 0. This one will be a 0, reason being is because minus 3 times 5 is minus 15, and minus 5 times minus 3 is positive 15. Then that will give us a 0. And then 1 minus 3 times 1, minus 5 times minus 2, this will be minus 3 plus 10 is 7. We agree, right? And then let's see now. Then we come to this one of 2, 1. Then minus 6 minus 5 is minus 11, right? And then we come to this one of 4 here. Then a 1 there, still a 1. And this is minus 12 minus 5 is minus 17, right? Then this one is minus 3c minus 5b. Minus 5b. Yeah. And then we are done with that row. And then we come to this one is row 4 minus row 2. If we check, this will mean 0. The constant of row 4 is minus 1, the constant of row 2 is minus 3. So I can just interchange them. This will become a positive, this will become a minus 3. And then we're going to have minus 1 times minus 3 is 3, then minus 3 is 0. Then you have minus 3, minus 2 is 6, plus minus 2, that's 4. And then here we have minus 5, which this is 15, 16. And then here we have minus 8, and then a 1 here. Let's see what that is. Minus 3 times is what? 25. And then this will be minus 3 times this, minus 3 times b minus 2a plus b. Yeah. And then we have this. Now we highlighted those again. We see that we are left with only 4 to change it to a 0, right? And then let's just change the last one to a 0 without recopying the rest. Then this one will just be row 4 minus row 3. Let's check the constants is 4, 7. So interchange, this will come here 4, 7 will come here. So now since we have this for the constants, now the formula is like this. This will be a 0, and this one remain a 0. Now let's say this one, it's 7 times 16 minus 4 times minus 11. Then this gives us a this will give us a minus, so it's positive 1 5 6, right? Then this one will be what? Let's see, 25 and minus 17. This one will give us 2 4 3, right? Then whatever that is up there, it was 1. So here was what? It was minus 3. Here was 1. So if I highlight this, we have the diagonals, right? So if I was doing this, obviously I could change this to a leading one, change this to a leading one, change this to a leading one. How many leading ones will we have? 4, right? So I avoided changing this to a leading one, but we yourself, we're going to change them in the test. I avoided changing this to a leading one because it was going to waste more time. So also this approach is also correct. You can change this to a 0 and then later you multiply this row by 1 over negative 1 over 3, 1 over 7, 1 over 5, 7, 5, 6, right? Then you change this to leading one. Realize that we have 4 leading ones. So it means that this set, it does span, right? But the only problem we don't know is, will it be linearly independent? You see right now? So we realize that for it to be linearly independent, we're going to take this. Let's take this last one. For it to be linearly independent, we're going to check this. The approach will be the same. Remember, the approach is going to be the same. The only difference is that here, we're going to say this is 0, 0. We agree right now? Instead of having A, B, C, we're going to say that is 0, 0. So let's check what we're going to have if we're checking linearly independent. We're going to check if we had 0, 0, 0. We're going to check if this is 0, 0, 0, 0. Then we remember that this was what? This was X, right? This was Y. This was Z. This was W. This was P. So we know from here that this would be 4Z plus 16W plus P, which is equals what? 0. Just because we have a free variable there, it shows that this can be expressed as a linear combination of other vectors within the set. You see, right? So we're going to check. This one is a free variable. It means that it will be expressed as a linear combination of these ones. Let's check how. We'll check this if, let's say now I change this ones to a leading one, right? If I change this to a leading one, this is how we find your constants. If I change this to a leading one, I'll have these constants to be expressed as this. But we can try now if it can work without changing those to a leading one. Since I've never checked that, we can check now to say this will be, let's see. The constant that we have here is what? It's 5, right? It's 1, it's minus 17. So if we have 5 times the first one is what? 1002, right? 1002 plus just 1, this one, so I won't multiply it. The second vector is what? It's 0 minus 3, 5 minus 1. 0 minus 3, 5 minus 1. Then the third constant is minus 17. Third one is what? Is 4 minus 216. Then the last one is 25 multiplied by the fourth vectors multiplied by 25. 7129. 7129. So when we add this, when we have this linear combination, this is going to be 5, 0, 0, 10, minus 3, 5, minus 1. What is 17 times 4? Minus 68. 17 times 2, 84. Minus 17. 17 times 6. Minus 17 times 6, right? 102 plus this one is 7 times 25. So 175, 25. Then this is 50. 25 times 9, 225. Then let's add this and see if we're going to get the last vector. So this is going to be 5 plus 0 minus 68 plus 175. We get what? Let's see, this is going to be 5. This is what? Plus 0 plus minus 17 times 4 plus 25 times 7. It's 112. If we check that one is what? It's not 112, right? So it means that for us to get this, we must put it down in It means that the one which will work is for us to change this to a leading one, leading one, leading one. Then we change this to a 0. We say right now, those ones needs to be zeros. So it means that this one, if we take it like this, it won't work. So we need to change it back to that. Change this to a leading one. So let me do this. Yeah. It means that what you can do, I'll give you guys this job, right, to go change this to leading one, leading one, leading one. Then this will be changed to a 0. Because it's cold now, we must go. So when this is changed to a 0, whatever that you'll get here, because this is going to be affected, remember, right, when we change this one, so choose that these are not the correct scalars. After these are affected, the first one will always be for this, the second one will be for this, the third one will be for this, the fourth one will be for this. Then you multiply. After multiplying, this one shows, this one already we know already that this one, the last one, this one can be expressed as a linear combination of these 3 or this 4. Already we know, because it's the one that is a free variable, meaning that there is available for any position.